So beginning the mock exam walkthrough. Probably do number 1 through 10 in the video, like 10 in a video, we'll see. But one thing I would recommend is having a separate sheet of paper from the mock exam out, because it's not going to fit very nicely on here. So I'm just going to go out here to the side, but I would have a sheet of paper if I were you. So let's get started with number 1. We've got, and I'm going to go really quick so you can pause and ask me questions if you need to in class, but I'm going to go as quick as possible. So number 1, we're going to say we've got to find the least common denominator. We're trying to solve, but my x's are on bottom. So right here, we need to factor this guy first. So this guy actually factors to x plus 3, x minus 3, difference of perfect squares. And I need to multiply everything by this least common denominator, which will always be this one that factors out. So if I multiply these, like multiply this throughout the whole thing, so that times that, that times that, and then here. So if I multiply this in here, we'll see that the x minus 3's cancel here, and I multiply in the x plus 3. So 1 times x plus 3 is just going to give me x plus 3. So I'm distributing this to the 1, this to the 1. And then here, the x plus 3's are going to cancel out. So I'm going to distribute the 1 to the x and the minus 3, so plus x minus 3. And then here, because this and this are the same, they're going to cancel out, and I'm left with 6. And here, if I combine like terms, I get 2x, the 3 minus 3 cancels out, and I get 6. And if I divide by 2, I get x equals 3. So one thing that we always say here is if you plug back in if you have a variable in denominator or in square root. Okay, so we have variables in the denominator, so we need to check this solution of 3 here. So let me erase this just so I can see it a little bit better. So here, I'm going to plug in x equals 3 into all of these. So 1 over 3 minus 3. So I'm plugging in x equals 3 where x was. And then plus 1 over 3 plus 3 equals 6 over 3 squared minus 9. And you might have already said, Mr. Hampton, you've wasted your time. Because right here, if I simplify that guy out, I get 1 over 0. I can't divide by 0, so we actually can't use this, and then there is no solution. Number 2. This one's a little bit easier. You just multiply by the least common denominator. You could cross multiply here, but you won't usually see it like this. So I want to get you in the habit of using the least common denominator. What is the first number that 3 and 4 both multiplied to? That's 12. So we're going to multiply both sides by 12. And really you end up cross multiplying, but I want to show you this skill in case it doesn't look exactly like this problem. So, because if I do 12 divided by 3, I'm going to end up multiplying by 4 into both of these. And if I do the same thing over here, I'm going to end up multiplying by 3 into both of these. If I do that, 4x plus 20 equals 6x minus 21. Let's see, if I minus 6x on both sides, or let's minus 4x, because you all hate negatives. Let's do that. 20 equals 2x minus, just making sure I got the same answer. Minus 21, add 21 to both sides. And that gives me 41 equals 2x, divide by 2 on both sides, and that gives me 41 over 2 equals x. And I'm going to check my answers a couple times as I do this if I get anything that looks a little bit weird, just to make sure that I've set it up right. So Give me 2 seconds. Yep, that's correct. So 41 over 2 is my answer. And this time, do I need to plug in? No, I don't have a x in my denominator. So 41 over 2 works. So here, this is a absolute value equation. So absolute value equation is, this is where I would use my silly way of remembering the grade or tate or, like you split it with an or, like you split a potato. So we're gonna split it, we're gonna flip the first one twice. So with graded or, it becomes an or in the middle, and I flip this sign and this sign in the first one. And then the other one, I write just like it is, 3x minus 2 is greater than or equal to 7. And to just solve, so 3x is less than or equal to, add 2 to both sides, so that gives me -5, divided by 3, x is less than or equal to -5 thirds. Or, okay, technically I should be writing this the whole time, but it's okay. I really just need to add this end step here. Add 2 to both sides here, that gives me 3x is greater than or equal to 9, divided by 3, that gives me this, okay? So this is one way you might see it, but if I was gonna write this in interval notation, this is pointing left forever. So I'm saying negative infinity to -5 thirds. Because it's got this equal sign underneath, I'm gonna write a bracket. And then or, so I put a union, bracket, 3 to infinity. Check the unit packet for unit 1 if you want to see a less than sandwich. Okay, so this one here, pretty easy comparatively. All I do is just isolate x, so I'm gonna -6 throughout the whole thing. -10 less than or equal to 2x is less than 2, divided by 2 throughout. So -5 is less than or equal to x is less than 1. So that is one way you might see it, but if we were going to write it in interval notation, an equivalent way to write this, because this has the equal sign, I put the bracket, -5, 1, parenthesis. So that is an equivalent way to say it.